Hey everyone, just got my hands on the 2025 Methods Exam 2. I haven't heard anything about it, so I guess we'll just find out. So a function that has a range of 6 to 12. So this one would have 6 plus 3, which is 9. This one would have 6 plus 6, which is 12, but 6 minus 6, which is 0, so not that one. 9 plus 3 is 12, and 9 minus 3 is 6, so it would be C. The next one is the asymptotes of a tan graph, and we can get that just by solving cos of the inside equals 0. So if we just do a solve cos of the pi times x plus a half equals 0 comma x, it looks like it's just every integer. So that there would be x equals k. K is an element of integers. This one here, which one would represent the reflection in the y-axis plus 2? So basically this point should be moved up to 3. So that's wrong. That's right. That could be right. That's wrong. And yeah, it should be, if it's reflected in the y-axis, it still should be going this way, not this way. So it looks like B. Consider the system of equations below containing the parameter k, the value of k for no real solution. So for no real solutions, the gradients need to be the same, but the y-intercepts need to be different. So what we can do is we can make these y equals mx plus c form. So k times x plus 3y equals k squared, comma y. So that's that, and then the other one would be 2x plus 2k plus 1 times y is equal to 6 minus 2k, comma y, and so that's the other one. And then what we can do is we can solve simultaneously for k so that the gradients are equal. So the first gradient is negative k over 3 equals to the negative 2 over 2k plus 1. And the other one would be that the y-intercepts are not the same. So that would be k squared over 3 is not equal to the other one, which is, looks like, I'll just put it on a fraction. So negative 2 times k minus 3 over 2k plus 1, and that gives both of these. K is equal to negative 2, or k equals 3 over 2. So that's C. Which of the following represents a function that has an inverse function? So if we plot both of these out, 1, 3 would be somewhere here, 2, 0 would be somewhere here, so there, and then 2, 1, so that already is not a function, so that's not A. Next one would be negative 1, 3, 2, 2, and 3, 1. That could have an inverse function because they don't have the same x or y values. So no x values are the same and no y values are the same. So I'll just make sure of the other ones. So here there's 2 y values that are the same, and here there's 2 x values that are the same, so it'll be B. The trapezium rule is used with 2 trapeziums to estimate the area bounded by the graph of y equals f of x, the x-axis, and the lines x equals 0 and x equals 1. For which function will the trapezium rule estimate be larger than the exact area? So it's a bit annoying, to be honest, but what we can do is we can just set up the formula. So the formula will be b minus 2 trapeziums between 0 and 1. So the width will be a half, so it will be a quarter. Basically the formula is b1 minus 0 over 2n, and then the number of trapeziums is 2, so 4, and then f of x 0, so f of 0 plus 2 times f of x as 0 plus the width, and the width is 1/2, and then plus 1 of f of 1. So we can just put that in the formula and define each one, and then compare that to the integral. So if we start off by defining f of x as 3 minus e to the power of x, then what we can do is we can check the trapezium rule. We can do it all at once, so we can actually do 1/4. So I'll do it as the top will be 1/4 times f of 0 plus 2f of a half plus f of 1, and then the bottom will be the exact area, and this fraction should be 1 or bigger than 1 if the trapezium rule is larger. So the actual area will be 0 to 1 of f of x. The only issue with this would be I have to be careful if the graph is negative. So that is less than 1. Then we can change it to the second option, which is x cubed plus 1. And then we can try this. That's bigger than 1, so it looks like B would be right. I'll just double check the rest just in case, because some might have negative parts. I should do this. So that's less than 1, and then the last one is if f of x is ln of x plus 3. And for that one, it's also less than 1. Okay. Consider the algorithm below in order the values printed by the algorithm are. So n starts as 17 and k starts as 5, and while n is greater than k, we define n minus k. So first of all, you would do 17 minus 5, which is 12. So 12 will be the first value, which is all of the options. And then, because 12 is still greater than 5, we keep going, and we do 12 minus 5, which is 7. And then, because 7 is greater than 5, we keep going. 7 minus 5 is 2, and we stop there, because 2 is less than 5. A random sample of n Victorian households is taken to estimate the proportion of all Victorian households that have vegetable gardens. The approximate 95% confidence interval calculated using this sample is that. The number of households n in the sample. So what we can do is we can just do a solve simultaneous for basically all we need is just n, and the first one is going to be p minus the 1.96 times the square root of p times 1 minus p over n, and that equals to the lower part of the confidence interval. And then I'll just copy and paste that and put a plus, and that's equal to the higher one, which is 0.552. And that what's happened? Maybe I'll put NNP. Okay, so 40. One day at a particular school, m students walked to school, and the remaining n students traveled to school using a different form of transport. So walked and then didn't walk. Of the m students who walked, 20% took at least 30 minutes, so greater than 30. And of the n students who used a different form of transport, 40% took at least 30 minutes. So this was 0.2 and this was 0.4. Given that a randomly selected student took at least 30 minutes to get to school, the probability that they walked to school is given by. So this here would be m students walked to school out of the total, so m plus n, and this one would be n over m plus n. Given that they took at least 30 minutes to school, so probability, what's the probability that they walked? So walked given greater than 30. Now this one here is walked and greater than 30, and this one is just greater than 30. So for the numerator, it's going to be m over m plus n times 0.2 and then all of that divided by greater than 30. So that would be this plus n over m plus n times by 0.4. And that gives m over m plus 2n, which is a. Consider that function and that one, the inequality f of g of x is greater than 0 is satisfied. So let's just see what f of g of x is. So f of x is 2x squared plus x minus 1. G of x is sine x. And then we can see what f of g of x is. And it's that. And we want that to be greater than 0. So in other words, this is basically a quadratic. We can try and factorize it. So it's like 2y squared plus y minus 1. And you've got 2y and y, and then 1 and 1. And the negative would go over here. So it's like 2y minus 1, y plus 1, and that's greater than 0. Now, if we look at that, that would have a positive a half and a negative 1, and it's a positive. So, in other words, sine of x would need to be, for it to be greater than 0, less than, this would be the 1/2, and this would be the, oh sorry, I've said it wrong. This is negative 1, and this is the 1/2. So it would need to be less than negative 1, but that's not possible. So, or less than or equal to negative 1, or bigger than 1/2, which is I think it would just be that one, because it has to stop at 1. And on top of that, it would be a restricted. This has a range of -1 to 1. The domain is R, so we would need to restrict the domain of this to be -1 to 1. But anyway, if we're just going from -1 to 1, that means it's over here, and -1 is over here. So we don't, somewhere over here. So the only thing is that the only part that it's bigger than 0 is the 1/2 to 1. Alright? And it's greater than 0, not greater than or equal to 0. Over which of the following time intervals did the daily price undergo the greatest average rate of change? So let's check. So day 3 to day 10. So 3 is over here, and 10 is over here. So that has a value of 30, just below 35, and this one is just above 36. So that's about 1. Now, if we look at day 3 to day 17, that's here, and 17 is over here. So that's already bigger. That's like almost 2. 14 to 21. 14 is here, and 21 is over here. That is exactly 2. And 14 to 28. So 14 is here, and 28 is here. So that looks like the biggest one. So it would be D. For a normal random variable, it's known that this and this. So if we draw that out, then we can say that greater than 200 is 0.325. And this is 0.589, so then this would be 1 minus this plus this. Okay, and then basically what we want to know is the mean and standard deviation. So for the mean and standard deviation, we can convert these to z values and then solve simultaneously. And for that, we'll start with an inverse normal for the first probability. So menu 553. The area for the first one was the 1 minus 0.589 plus 0.325, and mean is 0 and standard deviation is 1. So that gives that z value. And then for the other one, it would be an inverse normal, but it would be 1 minus just the 0.325 because we give the left area, and that's that z value. Now we can do a simultaneous equation for the mean and the standard deviation. The first one would be that is equal to, and then x minus the mean, so 180 minus the mean over the standard deviation. And the other one would be this is equal to 200 minus the mean over the standard deviation. And that would give 195 and 11, which is option D. Okay, which of the following could be the graph of g of f of x? So what happens is we plug in a value into f of x, and then that goes into g. So if we plug in 0 into f of x, that gives 0, and then we plug that into g of x, which should give us 0. So all of them should pass through 0, which they all do, so we can check a different point. What I would probably check is for the minimums. So for the minimums, we probably want to plug in a negative and a positive value, and they both give you the minimum. So when is f of x equal to a negative value? Over here, and then you plug, so you plug this positive x value in, should give you a minimum, which is that one, and then a negative value as well, so somewhere about here would also give you a minimum. So I think that's option C. And then for this maximum, you're looking for a positive value about here on f of x, which happens at a negative value, and that's also here. That's a good question. Let f be the probability density function for a continuous random variable. The k is a positive real number. The value of k is, so we just need to solve the integrals equal to 1. So the first integral from 0 to pi over 4 of k times sine x dx plus the integral from pi over 4 to pi over 2 of k times cos x dx equals 1 comma k, and it's root 2 plus 2 over 2, or what does that work out? I think that's the same as the option B, which is that equal to 1 over 2 minus root 2? Yes, so this is option B. The graph of g of x passes through the point 1, 3. The graph of this must pass through the point. So what's basically happened is this has been reflected in the x-axis, meaning the y-axis, it should be 1, negative 3. Then it's been moved up 1, so that should be negative 2. And then everything else happens to the x, so we can get rid of this. And then what's happened is you have translated 3 units right, so that would be 4. And then you've dilated by a factor of a half from the y, so that should be 2, negative 2. Consider the function h of x equals that. Given that the derivative h dash x has a range 0 to infinity, which of the following must be true? So the derivative of this would be a times 1 over x, so a over x, and it has a range of 0 to infinity. So this is going to be that, and well, if a is greater than 0, the range derivative, we just want this. Now, if a is just greater than 0, we have to actually take, it has to be a is greater than 0 and b is greater than 0, because we have to be talking about this right side of the log for that derivative to be true. We can just check anyway. This is defined, so the domain of the original should be positive. So this would be, it would be that b has to be positive for the domain of this to be 0 to infinity, and we take this. So it would be a and b are greater than 0. I think that's right. Given that the integral from 1 to 2 is bigger than the integral from 1 to 3, the function could be. So for option A, this would be a negative area, and this would be even more negative. So I think option A already, the smaller negative is bigger than the bigger negative. So option A is already correct. This one, you've got 1 to 2 is bigger than 1 to 3, which actually works out to be, no, I don't think that's right. This one, 1 to 2, that's definitely wrong. And this one, 1 to 2 is negative, and so 1 to 3 would be bigger, so A. Consider the following graphs which represent probability mass functions. Which pair of these probability has the same mean? So this one would be like 0.1 plus 0.8 plus 1.2 plus 0.4 plus 0, which is 0.9. Oh, well, this one would be 2.5. This one would be 0.1 plus 0.4 plus 0.9 plus 1.6, which would be 2.5 and plus 0.5, which is 3. This one would be 1 times 0.45, so 0.45 plus, that's 0.5 plus 0.15 times by 3 is 0.45, which would be 0.9, 1.4. And this one would be 0.2 plus 0.4 plus 0.6 plus 0.8 plus 1. So that would be 0.6 plus 0.6 is 1.2. So I think this one's 3. So that would be 2 and 4 are the same. Let A be the point on the line y equals x plus c, and B be a point on the curve y equals log base e of x minus 1. So B is a point here, and the other one is log like that, and A is a point on, oh whoops, it's the other way around. This is A and B is here, for example. If A and B are placed such that the line segment AB has the minimum possible length, and this length is root 2, then the value of C must be. So this one has a point of x ln x minus 1. And so we can do a simultaneous equation here, or just solve actually. So if we do a solve that the derivative of the square root of actually for this one they're placed such that the minimum possible length has the minimum possible length. So the first one, let's just get an equation for the two. So let's name the first point x1 and x plus c, or a and a plus c. So the first one would be the function, or the distance function, is defined as the square root of b minus a squared plus ln in brackets ln of b minus 1 minus a plus c all squared. We also know that root 2 is the minimum value. So if I just solve for the derivative equals 0, what happened here? Oh, I haven't put x. Okay, let's just say in terms of a. Okay, so that's a in terms of b. And we also know when we plug that back in, we get root 2. D of this equals root 2. And we want to know c. Okay, so it's, we've still got this. Well, they would be placed perpendicular. Okay, so let's say it's like that. These 2 points would be perpendicular. So if this is a plus c, and this is b ln b minus 1, we can do a simultaneous equation that the gradients of that line is perpendicular to the to 1. So it would be, this one would have a gradient of -1, I think is the other equation. So let's just do simultaneous, and we want to, let's just say just b and c, for example, or a, b, and c. And we can put 3 equations. Okay, and then the first equation would be, we can just put this one that we got. The next one can be this one. And then the last one is that the gradient of the joining them is equal to -1. So ln of b minus 1 minus a plus c over b minus a equals -1. What's happened? It should be made at the tangent. It should be made where this has a tangent equal to it should be made where this has a tangent equal to 1, or it's parallel. So this is 1 over x minus 1, and that should be equal to 1. And so x minus 1 equals 1, x equals 2. So this should be 2 and ln 2. So basically b is 2. So I guess now we can just figure out what c is. So I think c is 0. That was weird. I might have got that wrong. Let a be greater than 1 and consider the functions defined below. F of x equals a to the power of x, and that's that. Which of the following sequences of transformations when applied to x does not produce g of x? So dilation by a factor of a half from the y-axis. So that would mean you have a to the power of 2x, and then translation 1 unit in the negative direction of the x-axis. That would produce g of x. Dilation by a factor of a half from the y-axis. So that's again 2x, and then dilation by a factor of a squared from the x-axis would mean you multiply by a squared, you add the powers, that would produce. This one would be dilation by a factor of a from the x-axis, so a to the times a to the power of x would be a to the power of x plus 1. Then dilation by a factor of a half from the y-axis, so that would mean you have a to the power of 2x plus 1, and then translation 1 unit in the positive direction of the x-axis, so that would be a to the power of to the positive direction of the x-axis. Yeah, so a to the power of 2, and then x minus 1, and then plus 1, so that would be a to the power of 2x minus 2 plus 1. I don't think that one does it. Dilation by a factor of a cubed from the x-axis would mean you have a to the power of x plus 3. Then translation 1 unit in the positive direction of the x-axis. So that would mean, yeah, that would do it. That would be a to the power of x plus 2, and then dilation. So it's option C. All right. Find the coordinates of both stationary points of G. So I think this one here, if you take out x cubed, you would have 4 minus 3 x. So you have one at 0, 0. And then the other one, I'm just going to solve for it. So So 0 or 1, and then if you do that when it's 1, you have 4 minus 3, which is 1. So 1, 1. Sketch the graph. So we know that at 0, 0 we have a stationary point of inflection, and at 1, 1, and this is a power of 4, a negative power of 4, which means it would look something like that. So label the axial intercept. So this will be 4/3. Yeah, label the stationary points as well. So 1, 1, 0, 0, and then that's fine. Complete the following gradient table with the appropriate values of x and g dash x to show that g of x has a stationary point of inflection. So we know that at 0, it's flat. At, well, you can just say, oh, it's a table with appropriate values. So at x, it's 0. At, you can try -1. So what's g dash of -1? It's 24. But keep in mind, you can't do 1, let's just do a half, because 1 is the other stationary point. So all we have to do is do 1/2, and it should be positive as well, which is 3/2. Find the average value of g between 0 and 2. So this would be 1/2 integral from 0 to 2 of g of x dx, which is, now that would be 1/2 integral from 0 to 2 of this graph dx, which is negative 8 on 5. Let h be the result after applying a sequence of transformations to g such that h has a stationary point of inflection at 1, 0 and a local maximum at negative 1, 1. Write down a possible sequence of 3 transformations. So the stationary point of inflection was at 0, 0, and that's gone to 1, 0. And then the local maximum has gone from 1, 1 to negative 1, 1. So what we can just do, so we'll notice that nothing has happened to the y values. All right, so the only thing that's happened is to the x values. Now I'll just say that a times x plus b ended up at 1, and a times x plus b also ended up at, in other words, a times 0 ended up at 1, and a times 1 plus b ended up at negative 1. So we can see what the dilation and translation has been. Okay, so menu 371, solve for a and b. Oops, a and b. The first one is that b equals 1, and the second one is that a plus b equals, I didn't need to do this, negative 1. So a is negative 2 and b is 1. So in other words, you have a reflection in the, so you're affecting the x coordinate, meaning it's a reflection in the y-axis, and then you multiplied the x coordinate by, so it's negative 2. So you multiplied it by negative 2, that means you have a dilation by a factor of, sorry, I shouldn't say y-axis, I should say vertical. Dilation by a factor of 2 from vertical as well. And then you have this one here would be, what was the b? The b was 1, so translation b units, not b, 1 unit. And if it's been plus b to the x, that means to the right. So let's just double check that. If I reflect in the vertical axis, in the y-axis, this will be still stay at 0, 0, and this will go to negative 1, 1. And then if I dilate by a factor of 2 from the y-axis, then I multiply both by 2, so this will still stay at 0, 0, and this will stay at, this will become negative 2, 1, and then if I translate 1 unit right, this will become 1, 0, and this one will become negative 1, 1. Let x become a binomial. Why is a binomial here? Let x be a binomial random variable. Show that probability that x is greater than or equal to 3 is equal to g of p for all p is an element of 0 to 1. So that would mean that we've got 4c3, or you can say probability that x is greater than or equal to 3 equals 4c3 p to the power of 3, 1 minus p to the power of 1 plus 4c4 p to the power of 4. Now this is 4p cubed 1 minus p plus p to the power of 4, and you can take out p to the power of 3, and you have 4 minus 4p plus p, which is p cubed, and then 4 minus 3p, which if you expand is 4p cubed minus 3p to the power of 4, which equals g of p, and p is an element of 0 to 1 since it is a probability. Whatever. Okay, let f of x be that and g of x be that. The graphs of y equals f of x and g of x intersect at those points. Write down two simultaneous equations in terms of a and k. Solve them using algebra. So basically do this by hand. So we know that g of 2 equals 8. So 8 is equal to a e to the 2k. And the other one is that negative 12 is equal to a e to the power of other way around. 1 is equal to a e to the power of negative 12k. Now if you solve these simultaneously, you can divide both sides so you can get rid of the a. So 8 will be equal to, you can say 1, 2, 1 divided by 2. 8 is equal to e to the power of 2k over e to the power of negative 12k. And you can add the powers, subtract the powers, which means you end up adding them. So e to the power of 14k. And then, what's that? 14k is equal to log e of 8, which is 2 cubed. And that's the hint that you should change it to 2. So 3 log e of 2. And then k is equal to 3 over 14 log e of 2. I probably should show 2 cubed. Well, I'll do it in the steps. So 8 log e of 2 cubed equals 3 log e of 2. That means k is 3 over 14 log e of 2. And then you can plug that into 8 is equal to 8 e to the power of 3 over 14 times by 2 log e of 2. 8 is equal to 8 is equal to a e to the power of 3 over 7 log e of 2. And then you can say that 8 is equal to 8 a e to the power of log e of 2 to the power of 3 over 7. 8 is equal to a e, and then a times 2 to the power of 3 over 7. A is equal to 2 cubed over 2 to the power of 3 over 7, and then equals 2 to the power of 3, or 21 on 7 minus 3 on 7, which is 18 on 7. So that's a lot of algebra. Find the value of b, where b is an element of all real values such that g of x can be expressed in the form g of x equals a times 2 to the power of bx. So right now, okay. So let's just write what g of x is. So far it's a e to the power of kx. And we know that k is equal to, and we know a is 2 times 18 to the power of 7. But we will leave that. E to the power of 3 on 14 3 on 14 ln of 2, and a is equal to a e to the power of ln 2 all to the power of 3 on 14. So this is a e to the power of, a times 2 to the power of 3 on 14. And it says b is an element of all real values. So b equals 3 on 14. Use a definite integral to evaluate the area bounded by the graphs of f of x and g of x, where x is an element of negative 12 to 2. Give the area correct to 2 decimal places. So we can just do this on the calculator because it's decimal places. So let me just define f of x. F of x is negative 12, comma, what am I saying? X over 2 plus 7, and g of x is, and we'll just write it exactly using the show that values. So 2a, so which is 2 to the power of 18 on 7, times by e to the power of k times x, and k is 3 on 14, and then ln 2 times x. Okay, now what we want is we want to go to the graph and then sketch f of x and sketch g of x, and we just want the bounded area between the two graphs. So we can just do analyze graph, bounded area, this intersection point to this intersection point, which is 15.872. To how many decimal? To 2 decimal places. 15.87. And for the working out, you can say it's the integral from -12 to 2 of the top, which is f of x minus g of x. Let h of x equal f of x minus g of x. Write down an expression for the derivative of h of x. So all we have to do is define h of x as f of x minus g of x, and then we have to differentiate it. Okay, that's terrible. 1/2 h dash x equals 1/2 minus 6 times 2 to the power of 3x on 14 plus 4 on 7 times ln 2 all over 7. Should be a bit more clear that this is a power. Find the maximum value of h of x. So all we have to do is solve this is equal to 0, comma x, and it happens at -3, and that's within the -12 to 2, so we can take that, and then we can say h of that is equal to 1.72. Alright, let g inverse be the inverse of g. Find the points where the graph of g inverse of x intersects with the graph of 2 times x minus 7. What's 2? That's 2x minus 14. I think that's the inverse of this graph. So it's the points where the two inverses intersect. So I think it'll just be the inverses of these points. Yeah. So 2x minus 7 is the inverse of f of x. Therefore, they will intersect at 1 -12 and 8 2. Now, I wasn't showing my thing the whole time. So this is 2x minus 14. That's the inverse of this graph, just by observation. And so they will intersect when these swap as well. That's my guess, but I'll just double check that. If I just draw, I'll just get rid of these graphs, just for confusion. Now, here, if I go to a relation and I draw x equals f of y, and x equals g of y, you'll see that they should intersect at 1 -12, and the other point, which would be 8 2, which is right. Okay, so I think that's what I wrote. Yeah. Let f be an antiderivative of f that passes through 0c. Show that it is not possible for the graph of y equals f of x to pass through both of these graphs. So f is an antiderivative of f. F of x is equal to the integral of x over 2 plus 7 dx, which is equal to x squared on 4 plus 7x plus a constant c. Be careful, just say d. And then f of 0 equals c, therefore d is equal to. So that make sure you don't use the constant c and then also the y-intercept value they gave c. I think d will be equal to c. So yeah, d will be equal to c, because if you plug in 0, you get c. Therefore, capital F of x is equal to x squared on 4 plus 7x plus c. And then show that it is not possible for the graph to pass through both negative 12, 1 and 2, 8. So you can plug in. If f of negative 12 equals 1, then c is equal to, and you can solve that. So menu 3, 1, x squared over 4 plus 7x plus c equals to 1 comma c, and x is equal to negative 12, so c is equal to 49. Therefore f of 2 equals, and that should be 4 over 4, which is 1, plus 7 times 2, which is 14, plus 49, which does not equal to 8. So it doesn't pass through both of those. Alright, so I think that's enough to show. Just make sure. The graph of y equals f of x can be dilated by a factor of, there's more transformations this year, and also last year there was a lot. The graph of y equals f of x can be dilated by a factor of m from the x-axis such that its image passes through both of those points. Find the values of both m and c. So right now, it passes through. So basically f of x is equal to m times x squared over 4 plus 7x plus c. And we know that f of negative 12 is equal to 1, and f of 2 is equal to 8. And we can solve simultaneously for m and c. So I'm just going to define f of x as m times this, and then we can solve simultaneously for m and c. F of negative 12 equals 1, and f of 2 equals 8. So c is equal to 57, and m is equal to 1 on 9. I think that's right. Okay. Probability. The time taken for a driver to travel to work each day is modeled by that. Find the mean time taken. So that's a bit annoying of numbers, but the mean would be the integral from 29 to 59 of x times, so basically, make sure you do t over 121,530 times t minus 29 times 59 minus t cubed dt, and then on the exact, that works out to be 39. Find the standard deviation of time taken in minutes for the driver to travel to work each day. So you can basically say the integral from start to finish of t minus the mean all squared times 1 over 121,530 t minus 29, 59 minus t cubed, t all cubed dt, which is equal to, and square root of that, whoops. Okay, so integral, we'll start off with the square root of this integral, but basically it's, I'll just put this as 1, and then out the front I'll put bracket t minus 39 squared times this 10 root 14 on 7. The driver allows k minutes to travel to work each day. If the journey takes longer than k minutes, the driver will be late. Whether the driver is late on a particular day is independent of whether they are late on any other day. K equals 47, write a definite integral to show that the probability of the driver being late is 0.0847. So k minutes to travel to work each day. If it takes longer than k, then they will be late. If k is 47, write a definite integral to show that the probability of the driver being late is that. So from 47 basically to 59 of f of t dt is equal to 0.08704, and we can basically check that. So I should probably define f of t as that massive thing. And then we can say the integral from 47 to 59 of f of t. Oh, I defined it wrong. Be careful, that's still got the t from the mean. Okay, integral from 47 to 59 of f of t dt, and that should be 0.08704. Okay. If k equals 47, find the probability that the driver will be late on at least one day in a 5-day working week. So this is now a binomial. You can say L for late is binomially distributed. The number of trials is 5, and the probability of success is 0.08704. And we want to know the probability that L is at least one day. So L is greater than or equal to 1. And that would be menu 55B. Number of trials is 5. Probability of success is 0.08704. Lower bound is 1. Upper bound is 5. So that's 0.3658. For k equals 47, let p hat be the proportion of days the driver is late in any 5-day working week. Find the probability that p hat is between, okay, so probability that p hat is the same as the probability that L over 5 is between 0.6 and 0.4, which is equal to the probability that 2 is between L, which is between 3. Okay, so that's CDF from 2 to 3. So I'm just going to change this, and the lower bound is 2, the upper bound is 3. I should just double check. Yeah, lower bound, upper bound is the last two. So 0 to 4 decimal places is 0.06331. That's it. 0.0631. Find the integer k such that the probability correct to 1 decimal place of the driver being late at least once in any 5-day working week is 0.2. So we know late for k, whatever the one we don't know, is binomially distributed. The probability of success is now p, and the number of trials is 5, and the probability of success is p. And we want to know p such that probability that L of k is greater than or equal to 1 is equal to 0.2, which is the same that 1 minus the probability L of k is equal to 0 is equal to 0.2. So we can basically solve for p using the formula. So 1 minus, I don't know if the solve will do that with the binomial. I'll just do it with the equation just to be safe. 1 minus in brackets NCR 5, 0 times p to the power of 0 times 1 minus p to the power of 5, and that's equal to 0.2 comma p. So p is 0.04364 or 65, and then we want to know k as an integer such that the integral from k up until 59 of f of t dt is equal to 0.04365, and k should be equal to. So we can solve that. Menu 3.1, integral from k up until 59 of f of t dt is equal to this, comma k. And the only one that's between the 29 and 59. So this one, not that one. So 49.09. So 49. Okay. At a given traffic light, the wait time is modeled by a normal distribution with a mean of 2.5 and a standard deviation we don't know. So wait time is normally distributed, the mean is 2.5 and the standard deviation we don't know. If the standard deviation is 0.6, find the probability that the wait time will be less than 3.5 minutes. Okay, so give your answer to 2 decimal places. Menu 552, lower bound is negative infinity, upper bound is 3.5. The mean is 2.5. And the standard deviation is 0.6. That's 0.95, the 2 decimal places. Find the value of the standard deviation such that there is a 2% chance of the wait time, so probability that W is greater than 3.5 is equal to 0.02. So that means we have to do an inverse normal with the area being the other side, 0.98, to give that z value, and then we can solve that z is equal to x, which is 3.5, minus the mean, which is 2.5, over the standard deviation, comma s, and that's 0.4 to 2 decimals, 0.49. The driver passes through 3 traffic lights A, B, and C on their journey to work. The probability of each traffic light being red is shown in the table below. Let y be the random variable representing the number of traffic lights that are red on the driver's journey to work. Assume that each traffic light being red is independent of any other traffic light. Complete the following distribution of y. It's a bit annoying. So you can go to A and then B. So basically what can happen is one of them being red. Y is the number of traffic lights that are red. So it can be A, not B, not C. It can be not A, B, and not C. Or it can be not A, not B, and C. And so for this, that's 0.2 times 0.7 times 0.9. This is 0.8 times 0.3 times 0.9, and this is 0.8 times 0.7 times 0.1, and we add them all together. So 0.2 times 0.7 times 0.9 plus 0. I'm just going to copy these. This, but the first one was 0.8, and then 0.3, and then 0.9, and then plus, and the same thing, but 0.8, 0.7, and 0.1. So this is 199 on 500. I hope I've done that right. That's for 1. Then for 0, that would just mean the only way is 0.8 times 0.7 times 0.9. 0.8 times 0.7 times 0.9, which is 63 on 125. Now for 2, that would be either A, B, and not C, A, not B, and C, or not A, B, and C. Now, again, we can just, I don't have to write them out. So, we'll just change these. So the first one is A, which is 0.2, B, which is 0.3, and not C, which is 0.9, plus A, which is 0.2, not B, which is 0.7, and C, which is 0.1, and then the last one is not A, which is 0.8, B, which is 0.3, and C, which is 0.1, and that gives 23 on 250. And then all three of them would just be 0.2 times 0.3 times 0.1. Oops. Which is 3 on 500. Now I should just add these all up to make sure they add up to 1. So this plus the 23 plus 199, oh well, that one, and the 199. Okay, cool. The graph is sine x plus 1. Evaluate f of 2 pi plus 3. F of 2 pi over 3. So sine of 2 pi over 3 is root 3 over 2 plus 1. Find the exact values of x for which f of x equals 3 over 2. So I'll just define f of x as sine x plus 1. While I'm at it, I'll also check f of 2 pi over 3, which is root 3 over 2 plus 1. And then I'll also solve f of x equals 3 over 2, comma x, and put the domain, but 0 is less than or equal to x, which is less than or equal to 5 pi over 2. So x equals pi over 6, 5 pi over 6, and 13 pi over 6. There exist real numbers a and k on the interval 0 to 5 pi over 2 such that f of x plus k is equal to f of x for all x is an element of 0 to a. Find the value of k and the largest possible value of a. So what's happening is basically real numbers, any real number a and k, such that the graph is the same if you add a value. So what's the period? The period is 2 pi. Right? So right now, and that's between 0 and pi over 2. So right now, if I add 2 pi to my graph, it's going to be the exact same thing. So k is equal to 2 pi. And the largest possible value of a, from 0 to 5 the exist real numbers a and k in the interval 0 to 5 pi over 2 such that f of x is equal to for all x is an element of 0 to a. Because the domain is 0 to 5 pi over 2. So let's just draw both now. What's happened? F of x. Oh, it's because I've drawn the relations before. Just change it to function. Okay, let's draw f of x from 0 to 5 pi over 2. And then f of x plus 2 pi for the same domain. So they're the exact same. However, for x is an element of 0 to a, the largest possible value of a, well, the largest possible value of a is the 5 pi over 2. So, I don't know why. The only thing that's throwing me off is the round brackets, but that's still the largest possible value. Okay, that's a bit weird. So 1 second. Let g be between 0 and 5 pi over 2. G of x equals g is between 0 and 5 pi over 2. G of x equals a of x cubed plus bx squared plus cx plus d be a polynomial. Suppose that g of 0 equals f of 0 and g dash of 0 equals f dash of 0. Show that c equals 1 and d equals 1. Okay, well, we can just say that g of 0 equals f of 0, and f of 0 equals sine of 0 plus 1. Which is 1. Therefore, 0 plus, therefore d equals 1. You don't have to do anything more than that. And now, g dash of 0 equals f dash of 0. G dash of 0 equals f dash of 0, which equals cos of x. Is it cos? Is there anything else? Yeah, cos x plus 1. Cos of 0 without plus 1, which is 1. So that means c. So therefore 3ax squared plus 2bx plus c, g dash x equals that. Therefore g dash of 0 equals 1 means that c equals 1. Okay. If g of 2 pi equals f of 2 pi and g dash of 2 pi equals f of 2 pi, determine the area bounded by the graphs of y equals f of x and y equals g of x for x equals 2 pi. Give your answer correct to 2 decimal places. So they intersect at 0 and 2 pi. So I'm guessing we can use that information to find a and b now. I'm just going to define g of x. So I've already defined f of x. G of x define as a times x cubed plus b times x squared plus c, which we know is 1, and d is 1, so plus x plus 1. And then we know menu 371. I should also define df as the derivative of f of x, and dg of x define as the derivative of g of x. Now, menu 371, 2 equations, and solve for a and b. And then we can say that f of 2 pi equals g of 2 pi, and df of 2 pi equals dg of 2 pi. So this is what a and this is what b are. So you can write that as working out. So you can say a equals 1 over 2 pi squared, b equals negative 3 over 2 pi. And then the area bounded by the graphs, correct to 2 decimal places. So you just need to write an integral. I'm just going to draw them. So that's f of x. I'm going to get rid of this one. And g of x for 0 to 2 pi. Oh, I should change the definition. G of x define as that, but a is equal to that, and b is equal to that. Okay, so now we can draw g of x from 0 to 2 pi. And we want the area between the two. So what you can do is just get the we know the intersection points, but whatever. The 0 and the 2 pi. And so, and the one in the middle as well, which I think will be pi. Yeah, pi. So you can say the integral from 0 to pi of f of x minus g of x dx plus the integral from pi to 2 pi of g of x minus f of x dx. Now, what you can just do, you don't have to go and actually work that out, you can just use the bounded area. Analyze graph bounded area, intersection point to other intersection point, and that's 1.53 to 2 decimal places. Okay, oh, that's the last question. Let a equals 0, c equals 1, and d equal 1. So we know that g of x then, it's now bx squared plus cx plus d. Sorry, plus 1. No, bx squared plus x plus 1, because c is 1 and d is 1. Find b and r such that g of r equals f of r and g dash of r equals f dash of r. Okay, so can't we just solve that simultaneously? G of r, oh, I should change the definition. So g of x is now just bx squared plus x plus 1, and then now we can do this and say f of r equals g of r, and df of r equals dg of r. I'm solving for b and r. Okay, what about if I do the domain? 0 is less than r, which is less than 5 pi over 2. What does it say? Okay, well, that's not working. So we've got b, which is a positive quadratic. Oh, well, it could be a positive or negative. And g, which is f, which is sine x plus 1.
Okay.
Okay, whatever. So the graph is like this, and then we know that the sine graph goes like that. We know that at a point they have an intersection and the gradients are the same. So we know that br squared plus r plus 1 is equal to sine of r plus 1, and 2br plus 1 is equal to cos of r, I think. So well, cos, that means 2br has to be negative because cos can't be bigger than 1, right? And we know r is positive, so that means b has to be negative. This will be negative 1 over 2b is the x-coordinate of the turning point. Basically, these two graphs are always going to cut. They're never going to, it's going to have to be that the turning point is just touching the graph. So that negative 1 over 2b has to just touch the graph, I think. So it has to okay, let me just draw this out with a slider. So this is f of x from 0 to 5 pi over 2. And then we know that f of x, where's f of x? I need to redefine it. I did redefine it, g of x. So where is g of x? Okay, g of x. And that we can create a slider for b. Okay, so I think already this is satisfying. But if b is bigger than 1, okay, so the graph is not moving. Yeah, so the graph, it's just being dilated. And what do we want? We want r such that the graphs intersect. So where do they intersect? Well, r can't be 0. Okay, let's see if they're like, I'm assuming that this has to be low enough so that it touches again. They still only have one intersection point. Is b correctly defined? Yeah, b times x squared plus x plus 1. Oh, it's just 0 to 5 pi over 2 is the domain for this. Okay, so this is what's going on, and that's the sine x plus 1. And we want to know the point such that they intersect. And the gradient so that it's between 0 and 5 pi over 2. Oh, okay. If I do analyze and do this geometry intersection points, let's see if what happens. There's still just one. Oh, okay, there we go. So b has to be negative is what we found out already. But what can it go all the way up to? Negative 1? No. Negative half? No, it has to be such that the tangents are equal. Okay, so it looks like it's going to be somewhere over here. Now, how do we get that? That is what's that point going to be? F of r, g of r. Oh, it's the slider now. Okay, I'm just going to delete the variable. What's wrong here? F of r equals g of r, and I'll just say b is less than 0. How about if I do control enter? Oh, it gives it to me if I do control enter. Oh, okay, r is pi and b is that, but how am I supposed to get that as an exact value? Or 9, r is 9, but that's bigger than 5 pi over 2. So it's r is pi. Now if r is pi, then we can probably figure out what b is. So you can say r is pi and b equals okay, if r equals pi, b is negative 0.318. Okay, let me just say f of pi is 1. And what's g of pi? That. So why can't we just solve for menu 3, 1? That equals 1 comma b. Negative 1 over pi. That's it. That was so weird. Okay, but it's I guess a good question. And I think that's it. So that was the methods exam. Hopefully I didn't make any mistakes. Let's see if I just wanted to check the multiple choice. Looks about right. This one was pretty weird. Usually I'm not happy with. Usually you reject one. Let me go back up. negative k over 3 equals negative 2 over 2k plus 1, and this one is k squared over 2, k squared over 3. It's just a negative 2. And then I think that's fine. That's fine. Yeah. Yeah. Those were fine. I don't know, that one seemed a bit weird. Consider the function h of x equals a log e of bx, where a and b are elements of all real values except 0. Given that its derivative h dash x has a range. Yeah, so I think just the product has to be positive, because if they're both different, so it doesn't have to be true. That's one case where it has to be true. That's one case where it is true, but it doesn't have to be true. But if a is negative and b is negative, then doesn't matter. Then both of them will be fine. It will be up here, which is still positive. So that doesn't have to be true. This has to be true. That was a mistake. That's fine. That's fine. I think the rest was fine. I probably made a mistake somewhere else in this question, so if I did, let me know in these extended responses. So let me know if I made any more mistakes, but hopefully everyone went well. It was an okay exam. Little bit of tricky questions. It wasn't the stock standard, but it was alright. So hopefully everyone went well.